Question 7. Two forces P and Q act on a particle. The force P has magnitude 8 newtons and the force Q has magnitude 5 newtons. The angle between the directions of P and Q is 50. As shown, the resultant of P and Q is the force R. So R, if those two forces are pulling in this direction and this direction, will pull the particle somewhere over here. So I'm going to just draw a separate triangle for that over there. To find the resultant of two forces, I add them together. So I need to add together the horizontal component of Q and P. The horizontal component of Q is just 5, and P, as this is diagonal, we have to resolve into components. This one will be 8 cos 50. And Q has no vertical component, but P has 8 sin 50. So now we have to find the magnitude, and we can use Pythagoras for that. So the magnitude of R I have to square both of those and add them together, and then square root. Which is equal to 11.9 newtons. For part B, find to the nearest degree the size of the angle between the directions of P and the direction of R. So this is R, so we need this angle here. Now first of all, I'll have to, as I know the angle here is 50, I'll have to find this angle and then subtract it from 50. So if I go back to this triangle and label this angle alpha, to find that I'm going to use arctan of opposite over adjacent, and that is 31.1 degree, and then subtract that from 50 to give 18.9 degrees. Marks wise for this question, it's quite generous, this mark scheme for this question. There's a method mark for using Pythagoras, even if the values are not correct. So you could have cos or sine incorrect. You can have 1 or 2 errors, but then there are 2 accuracy marks. Deduct 1 for each error there. And then an accuracy mark here for 11.9. For part 2, there's a method mark for using arctan to find the angle alpha here. Then an accuracy mark for 31.1, a method mark just for that subtraction, which is crazy. And that's a dependent method mark, dependent on having worked all of this out, and an accuracy mark for 18.9.